Hello everyone, welcome back to another video with Case Solutions. In this video, we will be solving a linear inequalities problem of 8 is less than or equal to 3 minus 5z, which is less than 12. So we're going to treat this just like a regular algebra problem. Just keep a note of whenever we multiply or divide by a negative number, we have to flip our signs, and that means our inequalities. But other than that, we treat our inequalities just like equal signs. And our goal is to solve for z and have z left in the middle of our inequalities. So the first step is, let's subtract 3 from all sides of the equation. So we're going to do minus 3 here, minus 3, and minus 3. So that's our first step to get z by itself in the middle. So we know 8 minus 3 is going to give us 5. We're going to keep our inequality the same because we did not multiply or divide by a negative number. So it's going to continue to say less than or equal to. The 3 minus 3 is 0, so we don't do anything there, but we keep our now negative 5z, which is less than 12 minus 3 gives us 9. So now our problem reads 5 is less than or equal to negative 5z, which is less than 9. So now we solve for z. And now the way to do that is we need to get z by itself. So z is currently being multiplied by negative 5, which now means we need to divide it to cancel it out. So we're going to divide z by negative 5. And whatever we do on one side, we have to do it to all sides. So negative 5 here and negative 5. So 5 divided by negative 5 is going to give us negative 1. And because we divided by a negative number, we have to flip our sign. So originally it read less than or equal to, but now it's going to read greater than or equal to. So we flip the sign. The 5z, negative 5z divided by negative 5, the negative 5s are going to cancel out. So that's just going to leave me z in the middle, which is what I wanted. And then I flip my sign again here because I divided by a negative number. So it's going to read greater than. And 9 divided by negative 5, I'm just going to leave it as negative 9 over 5. So our equation reads, negative 1 is greater than or equal to z, which is greater than negative 5 over 1. And so to rewrite this equation, if you were using this to graph, I would rewrite the equation in the simplest of a number line. And since both of our numbers are negative, if you were to divide 9 divided by 5, you're going to get 1.8, or in this case, negative 9 divided by 5 is going to give you negative 1.8, which is further to the left-hand side of a timeline or a number line from negative 1. And so what I mean by that is I'm going to write it as negative 9 over 5 on this side and then negative 1 here, because negative 5 on a numbered line, negative 9 over 5 on a numbered line comes before the negative 1. If you were to divide that out, again, it gives you to the negative 1.8, which is smaller than negative 1. And so you want your smallest number on your left-hand side. And so in this case, I did the bracket for the negative 9 over 5 because I did not have an equal sign for that equality. It was just the less than sign. So I left my bracket there of negative 9 over 5, comma, negative 1. But because the negative 1 had an equal to sign, it was greater than or equal to, I'm going to include a bracket here instead of the parentheses. So I had an open parentheses on the left-hand side, but a closed bracket on the right-hand side. And so what that means is, if you were to graph this, z cannot be equal to negative 9 over 5, but it can be equal to negative 1. So the bracket means you can include that number, so z could be negative 1. And it can also be any number between negative 9 over 5 and negative 1. So it's not a lot of numbers, it's a couple of decimals. It's it's infinite amount of decimals, but that's what z is. And so if you were to pick any number between the negative 1.8, which is the number, which is negative 9 over 5, so I'm just going to rewrite it here. The negative 9 over 5 is going to give you negative 1.8, comma, -1. So that means Z is any number between that. So that can be -1.7, -1.6, -1.5, and all the decimals even between those numbers. So if you were to pick any number there and plug it back in your original equation, it should come out to be true. And also you can pick -1 because we can include -1 as Z. Hope that helps.